to Advent of Code. It's that time of year again. If you only watch this channel for the video games and you are not at all interested in programming puzzles, you might as well skip this playlist. But, you might find this interesting anyway. I don't know. You might be one of those people who just watches this channel just to listen to a voice while falling asleep, and I'm sure programming puzzles would put you right to bed. But, I'm sure there are people who are not into this stuff. So, but for those of you who are, it's December 1st again. So it's that time of year to do Advent of Code puzzles. Topaz puts these out every year, 2 puzzles every day from the 1st to the 25th of December. I'm going to be doing them in Haskell again this year. And I'm going to not really do much of a, how does Haskell work first episode as I did in the previous years. I figure if you want to learn Haskell, you can go watch you can go watch last year's videos or whatever, or go read a book or something. I'll be instead talking about my plan to solve the problem, and I'm sure I'll introduce some Haskell stuff as we go. But I won't start with the basics of the language. Day 1 took forever last year. I guarantee, in fact, that this year's episode 1 will be much shorter for the simple reason that I have already solved most of the problem, not on purpose. I was solving it on camera, or so I believed, but I got my my stop recording key switched mixed up with my switch Windows key or something like that. I still don't know exactly what went wrong. And so there was really no interesting content in there. You can see I have 1 star, which means I finished part 1 of day 1, and that was very fast. And we'll look at the puzzle in a minute, but it was very fast, obviously. Part 2, actually, I did a number of things wrong, and just as I finally got what I believe to be the final version, I realized it wasn't recording. So here we are. I'm gonna start. Anyway, I'll give you the puzzle, but as you can see from this timer here, I really don't try at all to compete for speed, as some people do. I was excited to start, so I started a little after 9. It was, which is when this comes out for me, is 9 o'clock. But not right at 9, trying to get on the leaderboard. I don't play for speed. I try to write code well and explain what I'm doing. So anyway, let's look at puzzle 1. Day 1, the tyranny of the rocket equation. Santa has become stranded at the edge of the solar system while delivering presents to other planets. To accurately calculate his position in space, safely align his warp drive, and return to Earth in time to save Christmas, he needs you to bring him measurements from 50 stars. And I like that this year there's some reason for stars to be relevant instead of just I don't know. The stars were trapped inside of, I don't even remember what the stars were about in previous years. You went and found stars hidden somewhere, I think, in the first year. Anyway, so it's kind of cool that this year the story is something where at least it makes sense that stars would be a thing. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. So that's pretty much the prelude or this anyway, is the prelude every year. This is kind of the theming for this year, and then we get to puzzle 1. The elves quickly load you into a spacecraft and prepare to launch. At the first go, no-go poll, every elf is go until the fuel counter upper. They haven't determined the amount of fuel required yet. Fuel required to launch a given module is based on its mass. Specifically, to find the fuel required for a module, take its mass, divide by 3, round down, and subtract 2. And then they give some examples of how this kind of arithmetic works. And they need to know the total fuel requirement. Calculate the fuel for the mass of each module, and then add together the fuel values. We can go look at my input. No peeking, this is part 2. And it looks like this, right? A bunch of large numbers, as you might guess. It's a very heavy rocket. So, here we are in Emacs. Oh, and I'm going to have to retell you guys about all my Emacs woes. So, on the one hand, my Emacs setup is better than it was last year, and on another hand, it's worse. Actually, are there ways it's worse? I'm not sure. But one thing that is true is that the thing I used 2 years ago, which was Intero, is deprecated now, and I could never get it working on this computer anyway. So this year I was like, how do you set up dang Emacs for Haskell stuff? And I tried Dante, which is like one of the new things. I was like, if you want Emacs for Haskell, try these 3 things. And Dante was one of them. And I asked people like, yeah, it works great. So I tried it and like, I forget, a bunch of stuff didn't work and I didn't know how to do things. So I just like couldn't get it to do anything. So forget Dante. And then I was like, okay, I'll try the Haskell IDE engine, which is using the language server protocol, which like if you're into language tooling is this thing that's been around for, I don't know, a little while. They're trying to standardize like a protocol for IDEs to talk to compilers and interpreters, basically, independent of language, so that you can write generic IDE tooling that doesn't care what language you're using, and like have extra features if it understands the language better, maybe. But I think actually the protocol is supposed to be able to say, here's all the things you could do, even. So I don't know. And I tried this, and I got somewhere. Like I could load files, and it would like present me little pop-ups about things I could do, but I couldn't get the colors right. It was kind of designed to work in like a full color windowed mode and not in like an 8 color terminal mode. And it wanted me to click on things with the mouse, and I couldn't figure out how to do it with the keyboard. So I was like, forget LSP. And it turns out that just like Haskell mode, the thing that's been around for years and years, works totally fine. I have a REPL. I have like highlighting of compiler warnings, compiler errors, and linter errors. I guess linter warnings, really. And it just works totally fine. So so I wrote part main. My main is like pretty much the same as it always is, right? I started with this in like my that's the other thing. Actually, it's already open somewhere. No. I wrote a little stack template for like an advent of code project, and I turned on the GHC options that like you're supposed to have if you're a good person. So that you don't write bad Haskell code, it warns you, right? Most importantly, like all warnings, and then like a few other warnings that like people have said come up on occasion and are important. I haven't played with them much, and it seems like they would come up too often for me, but maybe they would. I'm sure I've broken incomplete unit patterns before anyway. I have redundant constraints probably as well, so that'll be nice. And then I added a few libraries that like I often want. Containers, obviously you need sets and maps a lot. Parsec, parsing strings is very important when your input is a string, or a text file anyway. And regex applicative, a kind of like lighter weight parser that behaves like parsec but only handles regexes. And recursion schemes is another thing I've kind of wanted to play with, so I thought I'd include it in dependencies, and we'll see if I ever remember to use it. In fact, I could have used it for tyrannical costs, probably, but I didn't. And we'll talk about what tyrannical cost is when we get to part 2. But anyway, part 1 is just like take the input, parse it into lines, read each one from a string to an int, and then call part 1 and part 2 on it. And part 1 is very, very simple. You just map fuel cost over the list of ints, and you sum it, right? I wrote it in less time than it's taking me to read it to you. Fuel cost, also pretty simple. Actually, this is what I had written, because that seemed sufficient after part 1. Divide the mass by 3 and subtract 2. And that's what it told us to do, right? And when we run this, we get the right answer. I won't run it for you now, but it works. So let's get to part 2. Here we go. We're not still muted, right? Okay, good, good, good. I'm just like paranoid about hitting the wrong keyboard shortcut again. So, during the second go, no-go poll, the elf in charge of the rocket equation double checker stops the launch sequence. Apparently, you forgot to include additional fuel for the fuel you just added. And we should have guessed this was coming by the title being the tyranny of the rocket equation, right? This is kind of the famous like real world problem, and this is the term for it, is that like in order to put something into orbit, you need mass. It has some mass, and you need fuel to launch that mass, but the fuel you just added makes the thing heavier, so you need more fuel for that fuel, and now that fuel made the thing heavier, you need more fuel, and so like you need some just ginormous amount of fuel for every ounce you want to put into orbit, roughly, you know. And so they're talking about this, we're gonna have to solve the same problem. Fuel itself requires fuel just like a module. Take its mass, divide by 3, round down, and subtract by 2. However, that fuel also requires fuel, and that fuel requires fuel, and so on. Any mass that would require negative fuel should instead be treated as if it requires 0 fuel.
The remaining mass, if any, is instead handled by wishing really hard, which has no mass and is outside the scope of this calculation. So I believe I now have the correct answer, and I'm going to test that. Nope, looks like I have an infinite loop. Okay, good to know. Yeah, that's true, I sure do. Okay, at least it's easy to see. Still not the right answer. Okay, so the first attempt that I made to solve this problem was I wrote this thing called tyrannical cost, which took an int and returned an int. And it was like recursively basically computing the cost of the current mass, calling that fuel, adding it to the result, and then recursively calling itself with the mass of the fuel. And it returned an int instead of a list of int, right? And so this actually did type check. But of course you need a termination condition, and so I said, okay, well, if the mass is less than 0, actually I said less than or equal to 0, which was wrong for a different reason, then just return 0. And that, like, it gets you an answer that looks pretty plausible, but there's a problem with that, which it took me some time to debug, some number of iterations of this. And what I did in order to make it easier for myself to figure out the problem was I had tyrannical cost return a list of int instead. All of the costs recursively down the stack, right? First the cost of the module, then the cost of the fuel you just added, then the cost of the fuel at fuel costs, and so on. So that I could compare it to the example given here. And I finally realized that the last entry in my fuel cost was -1. Because 5 fuel, when I didn't have this max in here, cost 5 over 3, which is 1, minus 2 is -1. And so we were actually adding -1 to the result of a recursive call, and that recursive call did nothing, but we were supposed to not even add the -1. What's the problem? So I moved this max, the 0 checking, into fuel cost, and I was like, finally, I figured it out. Well, turns out I hadn't, right? Because you still need a termination condition here. Even if fuel cost returns 0, you have to stop at some point, right? So what we can just do is add another tyrannical cost of 0 equals 0 and equals empty list. And now we're actually set. And I could turn this back into producing just ints, but I think it's kind of nice that it tells you, like, it does a little accounting for you on where the total cost came from, right? Tyrannical cost, if we now run it in the REPL, we see, aha, 654, 216, 70, 21, 5, 0. And that's actually what the problem statement says we should get, right? 654, 216, 70, 21, 5, 0. So finally, we're correctly computing the fuel requirements for this. And if we now run this, we should get an answer pretty quickly. And it's very close to all the other answers I was getting, right? There you go, the right answer, finally. What an embarrassing performance. I made so many mistakes. But that's what programming is all about, you know? You make mistakes. And then you fix them and you learn something. We can't move on to day 2, obviously. What's left to do? There's a few things. First of all, what changes did I make here? Yeah, this is all fine to have one commit. Day 1, part 2. Anything else I forgot to show you guys? I still don't understand what the deal is with the stack.yaml.lock thing. Where does this come from? It was created like days ago. So I think this happened because like Emacs crashed, like actually dumped core when I was like trying out various Haskell modes. And I think that it was not actually any of the Haskell modes at fault, but like the package list packages command, if I press any keys like while it's in the beginning of loading, it just like dies. So that's kind of embarrassing. What else?
I guess what we could talk about. Okay, first of all, is this input.txt. You didn't see me download it, right? I wrote a little, not even a script. It's just like a curl command, right? That uses my browser's login cookie to download my input. I can't show it to you because it has my browser's login cookie in it, but it's pretty simple. You'll have to take my word for it. And we'll use that regularly in future days. I guess the other thing we could do, don't open Emacs again, go back to the Emacs you already have, is we could look at whether recursion schemes would be a good fit for any of these. I guess not, actually. Like, I don't know. Recursion schemes is this library based on an idea, as most libraries are, I suppose. The idea that, like, much of the recursion that you write is kind of like it has a lot of boilerplate. And there are common patterns of recursion that you can write that you can generalize across structures. You can write a thing called a catamorphism, and like many different kinds of structures have a single catamorphism. And when you like recurse over them as a tree, you're kind of re-implementing that part by hand in addition to your like business logic. For example, fold_r is the catamorphism for lists. And this is not a catamorphism because like our input argument is an int, not anything listy, and the catamorphism for ints is not very interesting. But it seems like it's sort of an anamorphism in the way that unfold kind of works. We're kind of unfolding this int to produce a list of outputs, and I think that's what an anamorphism is about, right? So like so how does anamorphism, like, what is the deal? Oh, I don't want the Wikipedia article. I want is data.fix in no? Okay. Haskell recursions. I'll show you guys once I find the right page. Okay, here we are in recursion schemes. I just don't like to let you guys see my browser when I'm like at a home page or like typing search queries in, because like you never know, right? This, you know, someone's browser is very personal, and it knows things about me that nobody else should ever know. I don't have anything in particular in mind. It's just like you never know what might show up when you give someone full access to your browser. So I try not to do that. So data functor base and data functor foldable, huh? So I don't really care about data functor base, I don't think. Or I'm in foldable, which I think is right. Yeah, type family base. Okay. So the base type for a list is like a list f. That's fine, whatever. But what I want to know is like, okay, unfolding. So we have a co-recursive type. A list is a co-recursive type. I'm pretty comfortable with catamorphisms, and I understand an anamorphism is basically just a generalized unfold. And I'm reasonably comfortable with unfold, but I don't know, like, I don't have the type signature memorized or anything. So I don't know exactly how to map what I know about unfolds to anamorphisms. And so here we have an A. So in this case, A is int and T is list. Why isn't T list of A? I don't know why this isn't TA. So Anna takes an A. Wait, so what the heck is T? Oh, T is, it's base TA. I don't quite get it, but okay. At any rate, specialized to lists, this means an A and a function that takes an A and produces a list F, which is basically either nil or a thing. And then an A to start with and produces a list of A's. So Anna has the signature that I expect for unfold. I don't totally understand how the base thing maps to that, but like, let's just for fun actually implement this with recursion schemes, right? So I want to import data.functor base, I think. Like, is this how I have to do this? And then import data functor. Obviously, this is way more work than just doing the thing by hand, but I wanted to practice, like, not writing my own recursion, right? And here is the one place in the whole program that I did recursion. Data functor base does not export listf. Well, that's exciting. How am I supposed to... Okay. Well, you know what? I'll just ask. Wait, what? It doesn't, does it not export Anna either? Oh, it's just telling me it's redundant because I'm not using Anna yet. Okay, that's fine. I don't care. I'm about to use Anna. I just need to know what type it has. Yeah, of course, that's not very helpful. Okay, so let's say we're gonna ask GHCI for some help here, or GHC, I guess. Tyrannical cost prime is also a function of int to list of int, and tyrannical cost prime equals Anna of how many arguments does Anna take? 2, right? Let's actually just say flip Anna f. Okay, now so my thinking here is, why is it upset about what arguments does Anna, what order does it take there? Oh, it takes the it takes the function first, so I don't need to flip it. It should just be Anna of f, right? Okay, and we'll handle the int by currying. Yeah, and so now it's telling me, okay, you need a function from int to list f of int and int, and that's what I thought. But where does list f? How do I? Oh, it's in data functor folder. Okay, so it's implemented in data functor base, but re-exported in foldable. Got it. So we want list f and all of its constructors. Okay, Anna f where f of, I already forgot the order of this thing. So f is going to be something that takes an int. Okay. F of mass. Let's just say f of 0 equals. I can't just write this, can I? No. Because we need the base. So what are list f? I crashed. No. Not in scope list f. Okay, so do I need to reload this again? Okay. Do I need to, like, close it, hide that, and then... Now I have list f. Okay, so what the fuck is a list f? It's a nil or a cons of a and b. Okay, that makes total sense. This is the kind of fixed point. This is something that is like list, but not recursive. So B is kind of like the rest of the list, and A is the thing here. So we can just say nil, and that should be totally fine. Equals nil, and f of mass equals cons of fuel and tyrannical costs. No? Hang on. How do you unfold? Ah, and in this case, we're going to put our new seed there, I think, which is just fuel again? the types check, no red underlines, right? So we're not actually building up a list. We're giving it a cons where we say the first part of the cons is the value you should have now. And the second part is what you should continue computing on. And it'll continue unfolding that until it gets to a nil case. So here's the big exciting part. Do we get the same result? It looks really similar, doesn't it? I don't need to scroll up in this friggin' terminal window. I can just look here. 484-1054. Yeah, that's what we got. So that's kind of interesting, isn't it? I think it's kind of cool. No recursion. Obviously, it's worse, right? This is a worse, uglier solution. But it kind of has the cool property that we didn't implement any of the recursion by hand, right? The concept of building up a list of values while maintaining some internal state about how to keep building up lists has been encapsulated in this ANA thing, an anamorphism. And of course, anamorphism is more general. Any functor can be built up this way, not just lists, which is just like super baffling, and I don't totally get it. But it's something I want to practice with, right? This is something I want to get to understand better in my own projects. And that's the kind of thing I like to use Advent of Code for, is to practice something new. It's not Haskell for me this year. I understand a lot about Haskell. It's not even really Tmux this year like it was before, because I kind of like got the hang of it. I still don't really use it in real life. But every so often I'm like, oh, I should use Tmux for this. And I have basic literacy in Tmux, but not much more. What is this yellow for? Just outdated. Interesting. Okay. Yeah, so, right, we said, please stop, or we said, please continue. Here's the amount that you should yield as the list's current item, and here's the thing you should continue using as your internal state. They happen to be the same in this case, which is too bad. By the way, you guys want to see something funny? Join cons fuel, right? Nope, I'm wrong. Why does that not work? Isn't it the same as, No, that's the opposite. I was thinking this is how you... Functions are a monad, and using the same argument twice is kind of how they do things. I guess maybe I actually do want this. No, that's still backwards. I don't know. There is some clever trick you can do here to use this argument twice, and I thought it was join. Why is it not? Oh well. Not worth thinking about at the moment. So let's just day 1 part 2 use recursion schemes. So there you go. A fun little thing to practice. And that was enough to round out a totally reasonable length for an episode, but still well below the length of day 1 last year. So as always, I don't promise to finish. Last year, I think I only really made it to like day 12 or something before there was one really long problem that did not seem very interesting to do, and I just stopped. So I do these for fun, and when they get annoying, then I stop doing them, and I don't promise to do all of them. So I'll do as many as I want to do, and I hope you guys enjoy them while I do. But that's all we have for today, and I plan to see you again 23 and a half hours from now, if you're watching this right when it was published, I guess. Anyway, that's all for today. Thanks for watching, and I'll see you next time.